Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, we have acquired many features that allows to create, transform, subject the data frames to calculation and in some way interpret the data within them. And today in this session, we are just going to discuss adding data to a data frame and of course merging between two data frames. Dear friends, a fast and common method to add data to a data frame is to insert value from another data frame or other series into them. The Panda library provides us with two different methods for this. One is append and next one is concatenate. Okay, in this session we will see that each of these two methods will allow you to add data separately. In fact, append is suitable for adding new data as a new rows of a starting data frame, while concatenate is suitable for adding new data as new columns of a data frame. Okay, let us just create some sample data frame that we will use to make example with this method. And yeah, here it's the one, dear friends, the data frame 1. Of course, we have seen a lot and discussed a lot related to this. Yeah, we are just going to create a randomly 4 into 4 matrix, and here it is our data frame 1. Let me just create something which is in zeros, and of course it is of data frame 2, and kindly have a note of it. Yeah, here I have just customized the index as like ABCD for data frame 1, and of course EFGH for data frame 2. Okay, by using this append, so what we are just going to do, kindly just observe, dear friends, the append method called on a data frame allows the addition of the data of a second data frame, so starting from the last row. So if the two data frames have a consistent structure, that is same label on the columns, we will have as a result a new data frame containing the values of both the source, that is both the source as a data frame and without any missing values. But here, yeah, kindly just have a note of it. This is what we are just going to have as a ABCD, that is the exact column, and here also the exact column is there. Once we append, kindly observe, once we append, how we just get, yeah, here we just go. So without any missing values, yeah, without any NaN, that is not a number, is appeared as the data set. As we are having, both the things are with the same columns. Okay, yeah, fine. Let me just make one more thing. See, it is also possible to add a single series to a data frame. In this case, using the append method is like adding a row to the data frame, and it is in fact a great way to do it. Okay, so when done, we then define here, yeah, here it is a series with the elements to be inserted in a row and specify the exact labels. Okay, so as those of the columns of our data frame, so which we just have as like it. Okay, so here let me just create it as like a series. Okay, here it is our series. And dear friends, kindly just have a note of it. Everything would seem simple and linear, but if we add a series like the one just we created in the data frame, kindly have a note of what is going to happen. So see here, we get an error. So can apply only a series if ignore index is equal to true. Okay, so as we can see from the error message, if we want to add a series to a data frame, we will have to add the optional ignore index parameter. So set to be as like true. So among the argument passed to the append method, so we have to use this and or have a previously assigned name now, so which we just say that is an attribute to the series. So if we ignore the indexes, setting in ignore index is equal to true, yeah, we will have the additional of the series at the bottom. So kindly have a note of it, how it's just going to happen. So here we just go with the added series, and we will have the addition series at the bottom of the data frame. And yeah, dear friends, as we can see, the series have been added at the bottom of the data frame, but the index label have been lost, which are replaced by a sequence of integer generated by the default. So therefore, ignoring the indexes is certainly not an optional operation. So a better method will be define the name of the series during its creation. So if it is not already defined now, so then we can just make it. So here, of course, see here, when we just make use of this, yeah, here we are just going to give it a already defined things, and then add it to the data frame. So note that the series name will become the index label of the corresponding row. So if you create a new series, specify name it with the desired label name. And yeah, here I have just passed a label name here as E. And let me just create it. So here the name E is there in the series. And yeah, we are just going to make use of the append, and yeah, let me execute it. And kindly just see here, dear friends. Yeah, we have finally achieved the desired result. So very often you will use the existing and defined series elsewhere. If you don't want to use the current name, yeah, you can always rename it as you like. Okay, whichever you want, you can just like it. And here, even though if you want to just make it, yeah, here it is the series name is that. And of course, you can just append it. So here you can just make it this as your desired. It is up to you, dear friends. Whatever you want, yeah, you can always rename it as you like it. Okay, now let me just move on to one more thing, that is appending multiple series. See, extending the concept further, the append method allows you to add several series at the same time. In fact, you can pass a list of series as an argument. So this will be added as row to the data frame in the same sequence as the inserted list. And dear friends, actually in our example, we could insert 3 new rows to the data frame, adding an existing series, and another 2 obtained by applying a simple arithmetic operations on the first one. So here, see here. So this is what the one series, and we are just going to apply some arithmetic operations, and we are just going to add it towards it. And now let me see here. So see here, this is what a new appending of multiple series to the data frame. Okay, now let me just move on to the concat. Okay, as for concat, the situation is different. So in fact, it is not a method, but a real function of pandas. So concatenate has no reference data frame from which to be called. So, but it is done directly from the library and accepts a list of the objects to be concatenated as an argument. So if in our case we want to concatenate 2 examples, so here let I just make some our 2 data frames here. So one is df1, let I execute it. So this is what our df1, and here it is our df2. So of course, yeah, we have some data frames here, df1 and df2. So let me just concatenate it by using the concatenate method. So this is what concatenate method, and I'm just going to make df1 and df2 as the concatenated data frame, and here it is the result. So kindly just have a note of it, how it happens. So as in this case, we will have an identical result to the obtained with the append method. So except that in this case, it is possible to concatenate several data frames at the same time and not just 2 alone. Okay. So by inserting them in the sequence in a list that is passed as argument of the function, yeah, you can just make use of here. So df1, df2, again df1, yeah, you can also make use of the same thing. So kindly have a look how it happens. Okay, a huge data frame we just obtained. Yeah, dear friends, actually, with this concatenator, that is actually, it is not a method, but it is also possible to concatenate together a data frame with series. So, which we have occurred when we just made use of an append. Now we executed something that is different behavior compared to append. Okay, so in this case, the series will become a new column of the data frame. So here the name of the series will become the label of the column, and if the label of the series correspond perfectly to those of the rows of the data frame, so we will have a perfect concatenation horizontally. So see here, this is how our series is. So let me just have, this is our series, and we have already given a name as like E, and so kindly have a note of it. This is what, and before executing, so let I just have what is there in the df1. So we have done so many things in df2, so I just want to concatenate it with the df1. And yeah, series, there we are just going to have it as like E as our column. So, and here I have specified the axis 1. Okay, so kindly have a note of it, axis 1, and here we just go with the result. So see here, it is a new column that is perfectly concatenated horizontally. And dear friends, this concatenation, yeah, we can also make it between data frames and series, which is that are not homogeneous. Okay, so kindly have a note of here. Also, with regards to this concatenate, if there is no perfect consistency between the row index of the data frame and those of the series, new rows will be generated with n values. That is not a number. Okay, values added where there was no correspondence. Okay, so let me just have that examples here. So see here, this is our series, and we are having 5 elements in this series, and of course 5 indexes, and let me just name it as like E. And yeah, here we just go, see here dear friends, in this index we don't have the label B. Okay, so we don't have the label B, and to the same thing, of course, what we have just done is we are having only A, B, C, D in the data frame 1, so where we don't have the E and F concatenation. So in this case, a new column corresponding to the series is added, and its value are aligned with the corresponding label if present. So here we don't have the B, so here we just get it as n. So that is what, otherwise nan value be added. Furthermore, if there are new labels in the series compared to those of the data frame, new rows are created in the data frame, which is also with the nan values. So the best way to manage them will then to be up to date to the user. So a better way to handle these inconsistent concatenation is to change the insert mode by setting the optional, that is join parameter to inner. So in this way, only the elements that have a concrete indexing correspondence between the data frame and the added series will be concatenated. So kindly have a note of it. Let me just make this as like an join here, and we are just going to make it as like an inner option. And when we just make here, so how it just going to happen? So see here dear friends, this is how, which are all we are having common. So common things is, yeah, of course we have A, C and D from the DF1, data frame 1, and yeah, of course it is also present in the series. Okay, so let me just move on. The next one as multiple concatenation. So however, if the data frame and series have corresponding indexes, they can be chained together even alternatively. So by extending the data frame horizontally, so let me just make it here dear friends. So df1 series and again series 2. So here series 2, yeah, we are just going to make an arithmetic incremental one, and the series 3 is arithmetic incremental 2 of this series, and again this df1. So see how our resultant would be. Yeah, see here dear friends, so ABCD, so till ABCD it is the exact of element of df1, that is data frame 1, and of course this E is the series and this is series 2, and next we have the incremental of 2 with series 3, and then again data frame 1. So this is how we can just make a multiple concatenation. Okay, dear friends, till now, yeah, we saw how the append and concat methods allow us to join together different objects such as data frame and series, both horizontally and vertically in a sequential way. But if on the other hand, our purpose of union is to merge them together rather than join them, the merging technique is the most suitable. Dear friends, this merge method like concatenated is also applied directly from the library and not on an instance of an object. And yeah, similar to this function also accepts as arguments the two objects to be merged, or rather on which to join. So which is nothing more than the, of course, SQL join. So anyone familiar with SQL and database will find the same logic applied to joins between SQL tables in the merge method. Okay, dear friends, of course, now let me just make use of the four different joins here: left join, right join, outer join, and inner join. Yeah, these values are passed to the how parameter. So here we are just going to make it towards the how parameter to set the joining logic. And another parameter is on. On, it is actually used to indicate on which table it should be based. Okay, so let me just define two data frames containing random integer. Yeah, of course, with the shape of 4 into 4 matrix, and yeah, with both column and rows and columns labels that are inconsistent with each other. So here we just go with data frame 1 and data frame 2. And kindly have a note of it. The data frame 1, yeah, we just have A, B, C, D, and the data frame 2 is with B, C, D, E. Okay, so yeah, let me just have this merging. So first of all, we just go with left join. So here, let's first apply the joining between the data frames. By here, we are just going to pass the how is equal to left. And once I execute, I just make you the discussion. So see here what we just done. So see here, dear friends, from the result, you can just observe the first thing is, the row labels. Kindly just observe the row labels, which is the index of the two data frames, are not considered during the joining operations and are lost as information in the new data frame. So replaced by progressive numerical labels. And this will apply to all joining operations performed with the merge method. And furthermore, here the column A that is present only in the left, that is left join here. Kindly just observe, which we just made it in the above. Yeah. So, okay. So that remains unchanged. And column B, which is identical to that of the left data frame, which joining is based on. So here we have just done the joining is based on. And next one, the column CX, DX, CY, DY are four new columns derived from the joining the column CD of the two data frames. That is CX and DX have remained identical to those of the left data frame CY and DY, which are insert values only in these indexes that have the same values on B in both data frames. Dear friends, the values shown are those of the right data frame. For all the others, it is enhanced with NaN. Yeah, kindly just observe. And to the last, of course, the column E, that is the column present only in the data frame on the right, has the value only in the indexes that have the same value on B in both data frames. So all other values are enhanced with NaN, that is not a number. Okay, let me just go with the right join. So using the right join, right logic on joining, so the result is perfectly opposite to the previous. So first of all, I just execute here. So see here. So from the result, yeah, you can see column A, okay, which is present only in the left data frame, that has the value only in the indexes that have the same value on B in both data frames. All other values are enhanced with NaN. And column B, yeah, is identical to that of the right data frame. And next, this column C, column CX, column DX, column CY and column DY are four new columns derived from the joining the columns CD of the two data frames, where CY, DY remains identical to those of the right data frame. The CX and DX are insert values only in the indexes that have the same value on B in both the data frames. So the values shown are those of the left data frame. For all the others, it is enhanced with NaN. And last, coming to the column E, yeah, it remains unchanged here. Okay, now let me just move on to the outer. So another different behavior in which we join with outer logic. So kindly observe, it is a new thing. So here we go. So in this case, all the values present in the two starting data frames are reported in the new data frame. So the only fully valued rows are those that have the same value in the column B. Let us kindly observe. So every values in the B are same, in which all the values of the two data frames are shown on the same row. So we have we have an actually CX, DX with the values of left data frame, and CY, DY and E with the values of the right data frame. So where there is no correspondence between the two data frame in the column B. And yeah, other the things, yeah, we have just NaN, values are reported. Fine. Okay, by applying the inner logic in the join of the two data frames, yeah, we obtain only the row or rows in which there was a correspondence between the two data frame on the column B, and all other information is excluded. Okay, all other informations are excluded. And yeah, dear friends, actually the inner logic is default of the merge method and may not even be explicitly expressed with the how parameter. Okay, yeah, dear friends, of course, yeah, in this session, we have just discussed about the case of append and concate. The resulting data frame will contain all the rows of columns from both data frames. However, in the case of merge, yeah, the resulting data frame will contain only the rows that have matching values in the specified columns or indices. And these operations are essential for combining and integrating data from the multiple sources or performing various data transformations. So by understanding how to use append, concate and merge effectively, you can manipulate and analyze complex data sets involving multiple data frames in Python by using this pandas. Yeah, dear friends, I hope you found this video helpful and insightful. And if you are interested in diving deeper into the topic discussed, yeah, I have provided the code used in this video in the description. Kindly just subscribe the channel and hit the notification bell to stay updated with latest uploads. Thank you, dear friends. Happy learning.